Okay, in the last one we worked with a polynomial. In this problem, we're going to be taking a look at a rational. Again, I encourage you to go ahead and hit pause, work this out for yourself for a form of review, help yourself get ready for the test, and then walk through this with me and make sure you got what I got. Okay, so the first thing we're going to do is look for the domain. Well, the first thing we're going to do is factor. Anytime you look at one of these and you see polynomials on top and the bottom that are not factored, we're going to want to get that into factored form. When I take a look at the numerator, what can I take out of the number on top? I think they both have an x in common, right? So if we take an x out, this leaves x minus 3. And when I take a look in the denominator, what can I do with the denominator? Well, this is a 3-term polynomial. So I'm looking for numbers that multiply up to -6. Oops. I'm looking for numbers that multiply to -6 that add to +1. What numbers are those? I think that would be what? +3 and -2. Those multiply up to -6, right? And they add up to +1. If you're struggling with factoring, please reach out to me because this is an essential component of this process. And if you can't factor, we're going to have a really hard time. So let's take a look. We got these, right? We've got these factored out. And now the domain of this, for the domain, we set the denominator equal to 0. Even though I have I don't have common factors right now. We're going to set the denominator equal to 0, and we get x plus 3 equals 0, which gives us a x equals -3 and x minus 2 equals 0, so we get x is equal to 2. So the domain, these are the numbers that I need to leave out of the domain. If I want to write this in set notation, I'm going to say x such that x cannot equal -3 and +2. If I was going to write this in interval notation, we would need to leave the -3 and the 2 out. So how would we write that? That would be these intervals right here. So that would be -∞ to -3 union -3 to 2 union 2 to infinity, right? This is -3 to -2. Or I'm sorry, this is -∞ to -3. This is -3 to -2. This is 2 to infinity. You don't have to write both of these forms. Use whichever one you feel most comfortable with. Are there any holes? If so, list the coordinates where the holes exist. Since I take a look at my, this is the one that we're going to be working with right here. Since I take a look up there at that and I don't see any common factors, we know that there are no holes. What are the equations of the vertical asymptotes? Well, after we have looked for holes and maybe tried to cancel those out, to look for the equations for the vertical asymptotes, these are where the denominator equals 0, again, after we have simplified for holes. So the vertical asymptotes are going to be at x equals -3 and x equals 2. And those are vertical lines. So I'm going to go ahead and I'm going to draw those vertical lines. All right, those take me a while to draw, so I went ahead and put those in there. We have x is equal to -3 and 2. We've got our vertical asymptotes. What is the equation of the horizontal asymptotes? Remember, there are 3 different cases. It's when the degree on top is greater than the degree on the bottom, when the degree on the bottom is greater than the degree on the top, or when their degrees are equal. Since their degrees are equal, what we see here is we're going to look at the leading coefficients on the top and the bottom. So when I look at the numbers in front of my x squared term on top, what is it? There's a 1 out front. When I look at the term on the bottom, what is the number out front of that one? It is 1 as well. So the horizontal asymptote of this is y equals 1. Let's draw that horizontal asymptote in as well. So I drew that one in. We're also going to label it y equals 1. Also label your x and y axis. That's always a good thing to do. All right, so what are the x-intercepts? To find the x-intercepts, remember we set the top equal to 0 after we simplified. So I'm going to look at my numerator, and we're going to set it equal to 0. So x parentheses x minus 3 equals 0. We set these equal to 0, and this gives me x is equal to 0. And x is equal to +3, because remember x minus 3 equals 0, move the 3 over. So I know I have x-intercepts. Now I encourage you to write these out as coordinates so you don't get confused about what is a coordinate and what is a point. So we're going to put 0, 0. Sorry, my graph does not like when I draw points. So 0, 0, and 1, 2, 3, 0. All right, so those are going to be my points. What is the y-intercept? To find the y-intercept, you plug in 0 for x. When I do that, I already know that 0, 0 is one of my points. That's going to be a x and y-intercept. But if you're not really thinking about it, you can plug it in. And when you plug this in, you get, you're going to get a 0 on top, right? Over -6, which is 0. So you know the y-intercept is also 0, 0. And I've already got that on here. On what intervals is the function increasing? This is the point where I think I need to look at a graph of this. So what I'm going to do is I'm going to move over. I'm going to put this into the graphing calculator, and I'm going to see what it looks like. And what I can see here when I get this graph is, here's what this polynomial looked like. And when I kind of take a look, if I compare this to what I have on my screen, you can see that it does look like it follows a similar pattern. So it's going to go up here, it's going to go through and up, and then it's going to cross through this x-intercept and head out. So I'm going to go ahead and draw that picture based off of what this looks like. So I'll use green for this. So this is going to come in from this direction, and then it's going to head up. Oh, that was bad. It should not cross that vertical asymptote. So it's going to come here, and then it's going to head up, and then it passes through here and goes through my x-intercept and up. Again, this is not the best picture, but I'm just doing a rough sketch of this. And then it's going to come up through here, go through this point, and head out towards that horizontal asymptote. So now let's think about this. Where is this function increasing? Well, it's increasing. Is it going up? It's going up over here, right? It's also going up on this piece, and it's going up on this piece. But this is not one continuous graph, so we can't write this as -infinity to infinity. It is increasing from -infinity up to this vertical asymptote at -3. Then it's also increasing from -3 to +2. And it's increasing from the other side of 2 all the way out to infinity, basically what my domain was doing. So all of these points are increasing. And then on what intervals is the function decreasing? Well, it's increasing for all those intervals. I don't see anywhere it's decreasing, so we're going to write none.